I just want to try with no brake hand at all and see what happens. Kind of. Yeah, I'm just going to try like that.
Ready?
Yeah.
3, 2, 1.
Oof.
It actually looked worse.
Yeah, it got worse, yeah. Yeah, I wonder why that got worse. It did catch.
Hey everyone, Phil here. Okay, maybe a quick recap. So this is the fourth video about the topic of cut resistance. If you haven't seen the previous ones, I would really recommend having a look at them to get the full picture here. The links are of course down in the video description. Now, almost 8 years ago, we set out to understand what cut resistance of ropes really means, how to measure it, and what details in a rope construction influences it. Out came the lab test you can see in the previous videos. And let's get to a mutual understanding here. A lab test for us in the PPE world should quantify a certain characteristic about a given product. And it should do this in a reliable and reproducible way. Reliable in this case means I do a test 100 times and get 100 results that deviate minimally from a mean value. Reproducible, on the other hand, means 100 different people do the test 100 times and get 100 results each that also deviate minimally from approximately the same mean value. And only then we have a good test about this characteristic. Yay! Well, that is only the first step, not the last one. In order to now know whether or not this test also makes sense, we of course have to test whether the quantified characteristics in the lab of different products also can be seen in practice. Because if not, then your lab test unfortunately tests something that doesn't matter. Now, this step 2 is often less exact, and one can often only verify the lab test by looking at, do we find the same tendencies that the lab test suggests? These must be the expectations, just to set this out clear. So the practice test is less exact, because if we could get exact results, what would we need the lab test for, right? So in this case, are there ropes that provide an extra of safety on edges, like the lab test suggests? And all of this we have done extensively in the past years, of course, just never got around to showing that stuff. There is potentially a lot to talk about. This is certainly stuff for more videos, as our tests involved lots of aspects from like how different stone types react when cutting ropes all the way to, of course, dynamic falling scenarios. And in recent discussions then with Tommy, we found it is about time to show some of that research. So first of all, Tommy, welcome to the Edelweiss Knowledge Base.
Yeah, so cool to be here.
Yeah, I mean, we have never so far talked about all the research we've been doing before or in the process of getting to that lab test. And this process, of course, then also at a certain point involved testing like real-world scenarios, like dynamic falls on edges. And so we thought now it's about time to show some of this, and we thought like who better to invite for this than you? I mean, you've been surrounded by sharp granite edges, big wall terrains, taking huge whippers.
Yeah.
I mean, with all your years of experiences, you must have had like experiences where ropes failed on you due to sharp edges. Maybe you can tell a few anecdotes.
Yeah, I mean, I would say my survival depends on the quality and integrity of ropes, maybe more than just about anybody. I've spent so much of my life, like you said, surrounded by sharp edges. And I would say I've had maybe 8 to 10 experiences. Like I can think of a couple right off the top of my mind that really stand out. One time on El Capitan, I was climbing a traverse pitch, and the gear kind of was like sagging between the pieces of gear, and it looped under a flake. And then when I fell, it de-sheathed the rope and exposed maybe 3 meters of core. And so that felt like a close call, you know. That was a scary one for sure. Yeah. But more recently, I had one that really kind of confused me. I was rappelling. Actually, a friend of mine was rappelling, and there was kind of a roof that we had to jump over, and it was a diagonal roof. And so it was just body weight. And my friend kind of jumped over the roof and then kept on going down. And then when we went to pull the rope, we noticed that it had a giant core shot in it. And my sense was that when he jumped over the roof, he kind of swung sideways, and the angle of the roof probably matched the rope just perfectly. So it cut it kind of like you would with a knife.
Yeah. And what I found interesting, that you said that this was a rope that was like optimized for cut resistance, actually.
Yeah, this was our most cut resistant rope, and so it made me start to question whether the tests that we have, the laboratory tests, are working a little bit. So I think the test that we've been doing here have really been to try and figure out real world scenarios and kind of verify that our hypotheses that we've made in the past are correct. And I also feel so lucky that when I have these things happen, I can come here and hang and spend time with you guys and really trying to figure out why. Most climbers don't get to do that, so it's pretty cool.
I mean, that's a little bit the idea of the knowledge base. But I think it's really interesting, the case that you just said, because I think it shows two things very, very well. One is that we can't make ropes bomb-proof. So speaking of cut-resistant ropes, and I think that's very important, never means like that they're like cut-proof, you can still make them fail.
Yeah.
And I think another interesting aspect is here that this happened in a static scenario. And I think that's been a little bit also the experiences that we've made when we came up with the test. Like, people were asking for those dynamic tests, because always like this is what especially climbers have in mind, right?
Yeah.
I mean, this test shows like a static scenario. Why don't we do tests falling? I mean, for one, like a static test is not so far off the real world scenario is what I'm saying, but like I think the question is very valid. Like, does the test reflect what we're seeing in practice in dynamics?
Yeah, and I feel like the tests we've done over the last days have helped me understand that a lot more. Like, in some ways, if there's rope moving through the system, it actually decreases the chance of a rope getting cut quite a bit, it seems like.
Yeah. And I mean, we've done some thorough testing.
Yeah, very thorough testing. Yeah, we've broken a lot of ropes the last few days. It's been pretty cool.
The plan now was to choose a testing setup in which the weakest rope of them, according to our lab test, would just fail, and then see if the supposedly stronger ropes on the cutting machine endure these same testing parameters. And that would provide us some evidence if the tendency the lab test suggests also hold up in the real world. And that made us finally end up with an 80 kilogram drop weight lifted 1.5 meter above the redirect, so effectively creating a falling height of 3 meters. And to fully concentrate on the different rope models first, Tommy, who was personally appointed as the belayer, was supposed to belay as passively as possible. So no active movement, just being a counterweight to the falling mass. So then the rope we want to test runs through one quick draw before it is redirected roughly 30 centimeters above the edge. In this configuration now, when the weight is dropped, the rope will hit the edge at about 120 degrees angle. The test is of course a binary one in general, meaning either the rope fails or survives. With this testing setup now, we have several parameters to adjust for. The rope, of course, the weight, the falling height, the edge angle, as well as, of course, the behavior of the belayer. As you can see, we started off with a perfectly horizontal edge. Not only is this the simplest scenario, it also separates as clearly as possible the shear load, meaning the rope is subjected to axial stress, from the cutting load, where the rope is subjected to radial stress. So in this first test, we test the shear load of a given rope and try to avoid any overlap with a cutting load. For the test specimens, we used 5 ropes, an 8.6 millimeter, an 8.8, a 9.8 mil, and then an 8.9 millimeter rope optimized for its cut value, as well as Tommy's favorite 6 millimeter cord. Apart from the 6 mil, all are dynamic single ropes.
I feel like this is a good replication of what could happen out climbing. It looks pretty sharp, but the angle doesn't seem so severe.
First, we want to just compare the ropes. So the belaying behavior should always be the same, and it should be as passive as possible.
Yeah.
And then when we've done this and see some results, then we're going to mix it up and try to behave in a different way in order to maybe make ropes that would cut on that edge, maybe not cut on that edge.
Great, I'm so excited we're doing this. I've always, the tests that we've done in the past have informed me a lot and made me too bold, and I'm wondering if this is going to take me back the other direction.
Okay, rolling. 3, 2, 1.
Yeah, there we go. There we go.
Yeah.
I mean, it's pretty informative to see what makes it break. I mean, it makes me feel like edges are something to really watch out for. I mean, I'm really curious to try the other ropes out. Yeah, I'm really, even though we put so much work into the ProTech ropes, I want to see how much better that holds. And the wrap line, of course. I do a fair amount of climbing on the wrap line, so I'm curious, yeah, how that's going to perform. And this is the rope I've done so much climbing on. Lots of simul climbing on this rope.
It could be any rope.
Yeah.
Okay.
Everybody ready? 1.
Oh, wow. Wow, way better.
3.0.
Is that what you thought was going to happen?
Let's have a look at what happens to the sheath here.
Oh, it's pretty soft. You definitely did some damage.
So you can see the core
Yeah, a
a little bit.
Yeah,
So it's pretty on the edge.
yeah.
Yeah, and you would definitely not use this anymore.
No.
Okay, quickly summing up again what we just saw. A different rope now with a slightly higher cut value just managed to endure the reference test setup. It is not really quantifiable here how much better it performed, but in the binary test result, it did not fail. And repeatedly tests show the exact same thing. Actually, in a second test, the sheath did also break. Okay, moving on.
Okay, so everything's the same as our last test, except we're doing a 9.8 millimeter rope, so a little bit thicker. Which I imagine it's not going to break because the 8.9 millimeter rope didn't break. Oh, it broke more.
2.9. So just now, next rope would be an 8.9 millimeter rope that is optimized for cut resistance.
Oh yeah, huh.
3.25. For now, we have the most optimized rope with the best results so far. Again, not quantifiably really, but it roughly confirms the tendency. The spot.
Oh yeah.
So this one now looks a little bit better than the Canary, doesn't it? Because you don't see the
a lot.
You don't see the core.
And also, it's way like the Canary was very soft afterwards.
Yeah.
This one's not that soft. It feels like a lot less damage. Yeah, like I have ropes like this. I'd still climb on it. I'd still climb on a rope like that.
Maybe you wouldn't if you knew what happened to it.
Yeah. Yeah.
And I can testify this from a manufacturer's point of perspective that we have in all the conversations we had in the past. Like, it sometimes makes us feel a little bit uncomfortable of what you're doing.
Yeah, totally.
So there's this like,
yeah, you're like, you could do that. It makes me nervous. Don't tell other people about it because we might end up killing somebody. Yeah,
so
totally.
maybe like talk to us a little bit like why this is so important for you.
Yeah, I mean, I think when I've come and done drop tower testing in the past, generally it's made me feel like I can push the envelope more because this stuff's strong. You know, even the really thin ropes are strong. Until this test, really, it's like when sharp edges get involved, all that goes out the window. And I think I really understand that way more now than I have in the past. So I've been really trying to figure out a way to only have to bring a 6 millimeter cord on big link ups in the mountain. So I'm really curious how this test is going to perform. I feel like it's probably not going to perform very well. We'll see.
Running. 3, 2, 1.
Yep, not what I thought.
Okay, I guess that was not so surprising. But maybe at this point, a little intermediate summary of the test results. What we have seen so far was that different ropes do perform very differently in such a dynamic scenario. Though no standard rope parameter that you are provided with your rope would have indicated how well the individual rope would have performed in this scenario. We saw thicker ropes fail before thinner ropes. We saw ropes with lower impact forces fail before ones with higher impact forces. We saw ropes with higher sheath proportion fail before ropes with lower sheath proportion, and so on. We did see, though, a similar tendency as our lab test indicates. And then, just that we have addressed it, nothing really groundbreakingly new or revelatory, but just we saw that in this specific scenario, impact forces for the climber were very consistently around 3 kilonewtons. A little lower whenever the sheath broke and a little higher whenever the sheath did not break. But be aware that these forces are very specific to this scenario and are not super informative beyond that. So it is time to change a parameter now and see how the results will change with it. In this case, and also for Tommy, we also wanted to figure out how much to get out of this magic cord of his. So now we changed the belaying behavior from passive to active, meaning Tommy should now behave in any way so that the belaying gets more dynamic. Anything he can think of. Let's see how far we can push it. Now the passive belaying is over.
Yeah.
So, and now we try to do you try to do any kind of behavior you like to make this hold the fall on the edge.
Yeah, okay.
Yeah? I'm gonna leave it up to you.
Yeah, we'll see. I mean, I want to try one with the pinch.
Yeah.
To see if I can
Yeah.
add dynamics with the pinch for sure. I just want to try with no brake hand at all and see what happens. Kind of. Yeah, I'm just gonna try like that.
Ready?
Yeah.
3, 2, 1.
Oof.
It actually looked worse.
Yeah, it got worse, yeah. Yeah, I wonder why that got worse. It did catch.
3, 2, 1.
No. Made no difference.
3, 2, 1.
Oh yeah, I forgot the backup,
Almost.
but still broke. Ah, dang it.
Okay, and after a few more attempts, we now let the actual best belayer have a go. Let's hear the solution.
What I'm trying to do is that as soon as the weight drops, I try to shorten the rope, pull a bit rope in, and then at the same time going down and being as
Jumping
dynamic
up.
as possible.
Yeah, so that's
Adding, taking out free fall height and adding dynamic as much as possible. Having
Yeah.
the braking distance as long as possible, but the free fall distance as short as possible.
yeah, cool.
That's the...
2, 1, go.
Oh, wow, nice work.
Now, I think this is pretty impressive. Of course, it should be clear, this is far beyond the permitted scope of application of that given product. But what it shows so remarkably is that the belaying behavior has a far bigger influence on your rope's safety than is often attributed to it. If there is one thing you should take away from this video, it should be that. So from here on, we started to play around, and it would be fun to show you all the tests we did, but we also somehow try to condense these videos on what we find is essential. But we came to another important point. What about situations where you do not have the possibilities to belay in a maximum dynamic way? For example, a common scenario that Tommy encounters are hanging belays. In a hanging belay, whether or not you are belaying from the anchor point or your harness, there is not much wiggle room for dynamic behavior. And this is where those belay assistant devices came into our heads. People often complain that these devices actually give hard catches, so that must be counterproductive, right? And guess what? It's true. If you belay in a completely passive way, or in real-world terms, if you don't adjust your belaying techniques, that's exactly what's going to happen. But as we already showed in an earlier episode, you can actually give catches just as soft with these devices as without them. In fact, the newer devices even open up more possibilities. With them, all of a sudden, you are able to use other techniques that make the catches even smoother and less long. It may take a little practice and a slight adjustment to your usual belaying behavior, but the result, as Tommy shows here, is impressive and impressively intuitive.
In belay, it's hard to create a proper body dynamic because you cannot really jump up. So I try to do it only with the brake hand.
Yeah.
So I do everything with my, or not the brake hand, sorry, the sensor hand. I
Yeah.
have to do it all with the right hand now.
For this one?
As soon as the weight starts to fall, I pull the rope in and then try to catch it with my right hand.
Got it. Yeah, yeah. That makes sense. So this time we're testing the skinny rope over an edge with the brake assistant device. So, see how it goes.
Nice.
I didn't get lifted at all. I mean, that was amazing. Like I felt like no pull on the belay hardly at all. It was like a really chill belay, but it also protected the rope and it just made it so much more safe all around. Pretty cool. Yeah, I mean, it just makes me feel like using the assisted braking device is going to help make it safer when there's edges involved, which I didn't anticipate that at all.
Okay, 3, 2, 1.
Yes!
It didn't break. Cool.
We've done tests in the past, and I also have to say, like, you've been pushing for, like, what if we climb on it and so on.
Yeah.
And there are certain, of course, like limitations to this as well, but like I think we were also quite surprised of how sturdy like how far you can push this.
Yeah, these tests have been interesting in that regard because I feel like if sharp edges are the exact scenario that cuts a rope, it's gonna cut your rope kind of no matter what. Like we can make incremental difference with making stronger ropes and using more cut resistant ropes for sure. But my big takeaway is just like edges can be quite dangerous.
I don't want to focus so much on the different ropes because there are certain ropes that we've seen behave better than others, but there's so much more that you can do to increase your safety by behavioring things, like how you behave, how you belay, how much weight is in the system. And of course, like at the end, the idea is like combining all of these factors, or as many as possible, is the safest way to go.
Yeah, and learning how to belay really well is actually way more important than I thought.
Yeah. That is it for now. The takeaway here should be there are many things that influence your rope safety in the context of sharp edges. Combining as many as possible is the safest way to go. For the next episode, take that all in, and then we start to play around with the angle of the edge, trying to look at the cutting loads in isolation. So subscribe to the channel and stay tuned.